Hey guys, this is Sean, and today I'm bringing you a tutorial on how to solve the last 4 edges of big cubes. So on big cubes, a lot of people are able to solve the first 8 edges, and then they get to these 4 edges, and the centers get all messed up, and they aren't able to match them up without having the centers messed up. So today I'm going to teach you how to solve the last four edges of any big cube, and yep, let's get on to it. Really, there's one trick to this, and it's to use an algorithm which is called the edge flip algorithm. So say I have this piece here and I want to flip it so that's down here and this one up here. I just use the algorithm R, U, R prime, F, R prime, F prime, R. And that puts those two switched. So what you want to do is make a group of 3 edges, 3 smaller pieces here, and then flip it and replace the centers. So for this, I would find the blue and white piece that needs to go here, which I see is right here. Actually, it's this one, because if I move this over, then those aren't matched up. So to get this over here, I need to use the edge flip algorithm first. And then it makes it so that I can move it over. And then to get it out of the way so that I can replace the center, you use the edge flip algorithm again. And then when you put it back, that's safe, and you have this over here. So then for the rest of the edge, you want to match up the other 2 pieces. So to do this, I have one here and one here. So I would flip this so that it's here. And then when you match these up, you can flip it again. And then replace the center. But if you just move this over and match it up, your centers are going to be messed up again. So to do this, you have to flip this 2-piece over here, like so. And then you take the 2 layers above the 3-piece and move them over. And then you flip the edge again. So when you replace the centers, the edge is also solved. So next what I would do is I would go for this green and yellow edge, because I see that I have 3 right there. So first I need to get the piece that goes here, which is over here. So I use the edge flip, and then move it over and edge flip again. Then I replace the center. And now I have to match this piece up with this piece. So I can move it over, then flip and replace. And since this is 2 away from this, I have to move the top 3 layers over twice, flip, and then put it back. And now on to the last 2 edges. I see that I have this block here, so I can just move this over and flip and move that back. And then this one gets a little bit confusing. So to do this, you can move the side that has the unsolved pieces. You can move one over and then flip this edge so that when you put it back, they match up. But you can't do it this way, because that takes one of the solved pieces out of its place, and when you try and put it back, that will be a different color. So you have to use the unsolved edge, and then when you move it over and flip, it should match up when you move it back. And then you just put it in the same way we've been doing. And when you get to this, you will most likely have a parity, and there are multiple different parities, but there can be just one algorithm that you use for it, which is the normal parity algorithm. For this though, since this is the only part that needs to be flipped, you, with the left and right turns in the parity algorithm, you do all 3 layers outside of what needs to be flipped. So if it were all 3 middle pieces that need to be flipped, you would do the algorithm with the left and right being only 2 layers. So the algorithm for this would be R2, B2, U2, L, U2, R prime, U2, R, U2, F2, R, F2, L prime, B2, R2. And that solves your last edge. And this is when you just go to 3x3 stage. So that should be simple enough.